Welcome to 6.3. We're going to be dividing radicals. We're going to be rationalizing radicals. We're going to be doing that same stuff with binomials. Hey, do you remember when we had imaginary numbers and we multiplied by fancy versions of one and complex conjugates? As I alluded to in the introduction, the processes that we're about to go over are processes that we've done before in this class, but we were just using i's earlier. Now we're going to use radical signs. So first we're going to start off with dividing. Divide coefficients first. That's easy enough. Then use the quotient rule. Notice this thing right here. So this is just a glorified way of saying that, I guess I should rewrite the end of it. A glorified way of saying that if the radical signs match, you just divide what's on the inside. So for example, as we go through real quick, these radical signs match, we're just going to divide those. These radical signs match, we just divide these two numbers, we divide these numbers, and then we've got an answer from there. Again, radical signs match, we just do these two things divided by each other. So what does that look like in practice? Let's try some out. So looking at the first one, I'm doing some stuff off screen. So I just took 12 divided by 2 into my calculator. Okay, I knew that off the top of my head, whatever. So that's 6. Then I'm going to do 160 divided by 5. That one I didn't know off the top of my head, but that's 32. So there's the start of our answer. But with radical signs, we always have to make sure that we are reducing. So then we're going to bring that 6 down. We can rewrite 32 as 16 times 2, and then 16 is the same as 4 squared. So that 4 is going to come out and then square root of 2. So now we've got 24 square root of 2. Now again, if you did not see how I got to this part, this is where you're going to do that factor tree, where you're going to do 32 divided by 2, and that's 15, 16, so on and so forth, and then you're going to pick the pairs that are going to come out. So looking at number 3 with the variables, it's the same thing. We are just going to deal with the variables so everything is under a radical sign here. So we're just going to deal with everything under a radical sign first, and then we'll deal with the radical sign. So if I'm just looking at these two right here, we've got x cubed divided by x squared. Remember our power rules. By divided, we're going to multiply, we're going to subtract them. So 3 minus 2 is just x on top. So then x9 divided by y to the 9th divided by y to the 5th is just going to be 9 minus 5 is y to the 4th. Don't forget there's a square root over all of that. So now we can look at this, and this is technically a 2. So we know that the square root of y4 is going to be y squared. So that's going to come out. And then that x is just going to have to stay inside of the radical sign because it's an odd number, so it's not going to come out. So here is our final answer. So again, we are just dealing with what's inside the radical, and then we'll add the radical back in and simplify. Moving right along, looking at number 5, everything is under a square root. So I'm just going to first take 48 divided by 16. And that is going to be 3. This is easy. So our final answer is square root of 3. 3 is not a perfect square. You can't take anything out. You can't reduce. Done. So number 7 gets to be a little interesting because if we just immediately take 7 divided by 64, you're going to get a decimal point. So that doesn't really simplify in any meaningful way. So what we got to do is we're just going to simplify the top and simplify the bottom using our cubed radical techniques, things like that. So 7 is not a perfect cube, so we're going to leave 7 underneath the radical sign. X to the 5th, at least one x cubed can come out, so that x is going to be on the outside. And then we're going to have 2 x's left over on the inside of the radical sign. So there's my top. My top is simplified. So then let's look at the bottom. 64, is that a thing? I think that might be a thing. So So I'm gonna consult my handy dandy calculator. Yeah, so I plugged it into my old school calculator. And the cubed root of 64 is in fact 4, so we're just gonna simplify that. And then the cubed root of y6 is just gonna be y squared. And again, if we were just to do y6, put the cubed root, that would be 3, so that's just gonna be y squared outside the cubed root. So this is our answer. In that case, we just simplified the top, and then we simplified the bottom, and it all worked out. Okay, rationalizing. So we've talked about this before. Remember back with imaginary numbers, we don't like I in the denominator. Well, we also don't like radical signs, period, in the denominator. So when we see something like that, when a monomial denominator, we're just gonna multiply the number and denominator by the radical. That's whenever I say we're gonna multiply by a fancy version of 1. That's why we can get away with it. And then if it's a binomial denominator, we're gonna multiply the numerator and denominator by the conjugate. So this is just gonna be a normal conjugate as opposed to a complex conjugate. But again, you're just gonna switch the sign in the middle of the two numbers and multiply by a fancy version of 1. So let's do it. If I were to look at number 9, we've got a square root of 5 on the bottom. So we're going to multiply the top by square root of 5 and the bottom by square root of 5. Square root of 5 times square root of 5 is 5. So on the bottom, we're going to have 2 times 5. On the top, we're going to have 3 root 5. Our final answer, we're just going to multiply the bottom, or we're going to simplify the bottom. 3 square root of 5 on top, 2 times 5, 2 times 5 is 10, and looks reduced to me. So number 11, we got a square root on the top and the bottom. That's fine. The only one that we are worried about is the square root on the bottom. So again, we're going to multiply by a fancy version of 1, square root of 7 over square root of 7. So then remember, under the square roots, they get multiplied together. So I'm going to take 12 times 7. So that's going to equal 3 square root of 84. And then our bottom is going to be 4 times 7. So if I'm looking at that 84, let's see, we're going to bring the 3 down. So 84 can be divided up into square root of 4 times square root of 21. The bottom is 4 times 7, which is 28. So now we're going to have 6. So that guy turns into 2. 2 times 3 is 6. Square root of 21 all over 28, which we can reduce the 6 over 28 until we get to 3 over 14, and we leave that square root of 21 in there because we can't pull anything else out of it. So again, we are just worried about the radical signs in the denominator, and the rest of it, we're just kind of doing the math to deal with it. Square root of 2 on the bottom, and that's the only one that we have a problem with. So that's the only one we're going to multiply by. We're going to multiply by a fancy version of 1. But here, because this is a binomial, we're going to put that in parentheses, and we're going to make sure that our square root of 2 hits both of those numbers, and we keep them separated by a minus sign. If they do end up being the same, then we can combine them, but we can't do that with addition and subtraction until they are the same. And they're not going to be the same, so whatever. Anyway, so let's do some math. So on the bottom, square root of 2 times square root of 2 is just 2. Square root of 2 times square root of 8. 8 times 2 is 16. We're going to have square root of 16 minus root 2 times root 2 is root 4, or just 2, because I know that the square roots will cancel out. And then that 16... let's see here, what can we, 4 times 8, yeah, so 16 is still a perfect square, so 16 can then be further reduced to 4 minus 2 all over 2, so then we got 4 minus 2 on top, so we got 2 over 2, oh, that's cute. Nice easy answer for some good old complicated math. When we look at this, this is an even number, even number, even number. So we can at least cancel out a 2 out of all of those things. And that 14 is going to go to, yeah, so I think it's just 2 in this case. So 16 divided by 2 is 8. 4 divided by 2 is 2. So we do not touch the square root though. We are only canceling this part right here. And then 14 divided by 2 is 7. So yes, you need to reduce your radical signs. You need to reduce your fractions. Looking at 17, we are going to multiply by that fancy version of 1. We're just going to change the sign for our conjugate. So we're going to multiply by 1 plus 4 root 2 over 1 plus 4 root 2. Don't let an extra coefficient confuse you too much. So the top, which is going to be a little bit easier, square root of 3 plus 4 times square root of 3 times 2, which is square root of 6. So now we're going to come down here. Again, I'm still not that great with my pattern, so I'm going to do 1 times 1 is 1. 1 times that is positive 4 square root of 2. This times that is negative 4 square root of 2. This times that is negative 4 times 4 is 16. Square root of 2 times square root of 2 is times 2. So notice that these guys are still multiplied together. So these two are going to cancel out. That's fine, but you have to multiply these together before you add it to that one. So that's what we're going to do. Cancel these two out. This is going to be a negative 32, and then 1 minus 32, so that's going to be a total of negative 31. So that's going to go right here. And I'm just going to go ahead and circle it. You could definitely move your negative sign up there and right there if you wanted to, but I'm just going to leave it like that because close enough. So we're going to simplify this into we're going to cancel out a negative 2. So that means we're going to go to 4 plus 2 root 7 over 12, which I should have canceled out a 4 because now I just have an extra step, but that's okay. I'm okay with having an extra step, but that's just me. So our final answer is going to be this guy right there. And then we're going to come back and mark this wrong because that is wrong. That should actually be a 6 because we divided everything by 2. 12 divided by 2 is 6, not 4. So we're going to go ahead and give Mr. Lin a -1 point because he can't do math.